mode. Just kidding, okay? We'll just go normal mode, okay? Now, everything that you've been learning about sine and cosine and periodic functions is all going to come into fruition because you're going to finally realize, oh, this is what sinusoidal or periodic functions are for. Okay, and we're going to do that with a series of examples, and I'm going to show you as many as I can on this video without the video being too long. Also, I'll show you some things that you can do on your calculators, okay? Now, here are the problems that are listed here that are good for the good for you to study, you know, from the book, from the textbook, okay? Now, we're going to do this first example here. We have this buoy, okay? A signal buoy in Chesapeake Bay bobs up and down with a height of h of its transmitter in feet above sea level, modeled by this, which is a sine graph, right? It has a little vertical shift here. During a small squall, its height varies from 1 to 9. Now, think about this. Its height varies from 1 to 9. So, what is that trying to tell us? Okay, think about that. And I think you were thinking, oh, 1 to 9? Min and max? Ooh. Okay, good, okay? And there are 3.5 seconds from one 9-foot height to the next. Wait, what is that trying to tell me? Process all this. So think about that. 1 foot to 9 foot. Oh, that must be the min, right? That's got to be the min. And this has got to be the max, don't you think? Okay, and it also says 3.5 seconds from one 9-foot height to the next. So isn't 9 the max? So it goes from max to max. It's telling you something, right? It's going from max to max in 3.5 seconds. Oh, so what does that mean? So that's, oh, period! So these are the kind of questions I might ask you, okay? What is this describing? Okay, and this is definitely your amplitude, right? It has something to do with your max amplitude. But you know, 1 to 9 is not your amplitude, right, guys? It's your midline to the min, to the max. That's your amplitude. So I want you to keep all that in mind, okay? All right, so let's organize everything. I think some of you guys have a good idea, so why don't you just turn off the video and start writing the equation yourself? Because your goal is to fill this here. Looks like it started at 5 feet already, right? Okay, so start there. Okay, so finish it if you want to, okay? So we're going to go height 1 to 9, okay? That implies that the amplitude, remember, it starts. Vs start at 5. So what's the distance from 5 to 1 and 5 to 9? I think you guys are getting it. A equals 4. Woo! A is finished. Awesome. Okay. What else? Well, we know for sure, right? We know for sure that the period is 3.5. Okay. Wait, I'm going to actually write this better. Okay. 3.5. Okay. Period is 3.5. 3.5. Okay. So if you want to write it as 3.5, which is 7 over 2, it's easier to calculate this way. You can do that too. Okay. Period is that. But period actually is 2 pi over b, and we need b, right? So what do? 2 pi over b is equal to 7 over 2. So 4 pi equals 7b. B must be 4 pi over 7. So, wait, are we done? We are kind of done, right? We got the b now. So let's put it all together. I'll write it here cute and a little slanted. Height is equal to amplitude, which is 4 sine 4 pi over 7t plus 5. Now, what is this equation showing us? It's showing us that this buoy, it has 5 feet. It has started at 5 feet, but it'll go up and down continuously. Of course, it speeds up, you know, when there's higher winds, right? That's what it's doing. And this sinusoidal periodic function here, it actually shows you the movement of the buoy. Okay, now, I'm not going to do the tsunami wave, so we'll skip it. Woohoo! Okay, we're going to do the Ferris wheel. Ferris wheel is a lot more fun anyways, right? Ferris wheel, okay? Now, I want you to understand how a Ferris wheel works. Ferris wheel is, it goes around in a circle, right? Okay, it goes around in a circle. Just keep that in mind, okay? All right, a Ferris wheel Ferris wheel, 50 foot in diameter, okay? Just have those ideas and highlight some of the important things. In diameter makes 1 revolution every 40 seconds. So that means it goes around once, right? Sorry, it goes around once in 40 seconds. We also know that it's 50 feet. 50 feet. You're wondering how long is 50 feet? Well, 50 feet, I don't know if you know this, but Miss Chang is about 5 feet-ish. So maybe 10 of Miss Chang. That's how big this Ferris wheel. I mean, I'm pretty tall, so I think 10 of me is not that tall, okay? So don't be scared about this Ferris wheel if you're afraid of heights, okay? Makes 1 revolution every 40 seconds. Okay, makes 1 revolution every 40 seconds. Makes 1 revolution. I wonder what they're trying to tell you there. Makes 1 revolution in 40 seconds. If I start here, 1 revolution, 40 seconds. 1 revolution, 40 seconds. So think about that. Why are they telling you that? If the center of the wheel is 30 feet above the ground. So remember, the ground is here. The Ferris wheel, it's not touching the ground. It's not touching the ground, you weirdos. If the Ferris wheel was touching the ground, then it wouldn't be able to spin, and the people that are riding on it could actually really hurt themselves, right? If you think about it. Like if you're down here and you're touching the ground, right? If you're like down here and you're touching the ground, you'll die because you'll skid the ground, right? So there's a little bit of, it's 30 feet above the ground. So if you have the center here, you got to understand this whole thing is 30 feet. But what does that tell you about this part then? I hope you understand that's 5 feet. That's about as tall as Miss Chang is. Okay? Great. What does that tell you about here to here and then here to here? You're right. 25 feet, 25 feet. Now, these are all conclusions. And I don't know if you remember the last exam. Sometimes we ask you to draw these diagrams and identify all the parts. And I think it's important that you could do that yourself. Okay? So again, this is implied that it's 5 feet. This, okay, and this, it's 25 and 25, which adds up to 50 feet because that information was given to us already. Okay, now we're ready to start. Okay, and I want you to also write here 1 revolution every 40 seconds. Okay, all right, here we go. Woo! So I feel like we did a lot so far. Okay, we've done so much. Okay, let's start. Because we need to formulate an equation, and I'm going to formulate an equation in this format. Y, B, and let's do, oh, sorry, I forgot the cosine or the sine. Yeah, you're wondering, what should I do? Now, I'm going to actually write it in this form, and I want you to think about why we chose cosine for this. And maybe it doesn't matter which form we chose, but why a cosine would make more sense for this particular case, okay? Okay, first of all, let's do the easy parts first. Let's do the easy parts first. What's the amplitude? Yeah, amplitude is what? 25. Do you understand why it's 25? Okay. Think about why it's 25. Okay, okay, okay. And let's do 2. You know what we should do? We should do this part. It says here, the center of the wheel is 30 feet above the ground. Above the ground. That implies to us that D is 30. Midline is 30. Because midline actually gives us from here to here. All right? Okay? It's like above the ground here, and then it's below the ground here, if you think about it. Okay? Okay. We got so much so far. Let's do third item. Oh, sorry. Let's do the third item. What's the third item that we need? We need a lot. We have A so far. We have D so far. We still need B, right? We need B. But what information do they give us? When is the first cycle complete? Right here, right? Right here. What is that called? In the sine or cosine world, it's called a period. Is the period 40 seconds, you were asking? Is it? And how do you know that? And how do you justify it? Because it happens every revolution, right? Every revolution or every cycle. Every revolution that you go around a circle is 1 cycle, is 1 revolution, which is a period. It's how long it takes to go around the whole full circle. So period is 40 seconds. And you're right, it's assumed that we can make that hypothesis, okay? So period is 2 pi over b, but we know that period is 40, so we're going to solve for b now. So 2 pi over 40 is equal to b. Have you noticed that period is equal to 2 pi over b? So b is actually equal to 2 pi over period. You could write the equations that way, the relationship, okay? Maybe you knew that already, so ignore me, okay? So that means pi over 20 is equal to RB. So we have our equation. We have our equation, okay? We have an equation. And you know what? Okay, so let's go to a fourth, okay? Start writing an equation. Y is equal to amplitude, 25. Cosine, our B is pi over 20, okay? Our pi over 20. Okay. Where am I? Okay, we got that, okay? We have this so far. Yep, okay. And then we have our pi over 20. And you know what, you guys? Why do we have to have a phase shift, right? So it's going to be x, right? X minus 0 plus, what's our up and down? What's our up and down? We start at 30. That's our D. So we've fulfilled all this information that we've already had, okay? And we just input it into our equation. And how do you assume that there is no phase shift? Well, usually we start at, I'm going to actually do it this way, okay? I have a question for you. There's a couple of things I want to discuss. This has all to do with time, isn't it? Doesn't it? It's all reference to time. So I'm going to do y of t. It makes more sense this way. As time is going, right? As time is going, what's happening, right? You're traveling. Okay? And when you start here this ride, right? Okay? You start here this ride, and you're starting at the low point or the negative part. So see if you understand why. It would be negative 25 cosine pi, I made a mistake here, 20, okay? Pi over 20x, okay? Pi over 20, not x. I'm not going to put an x either. I'm going to put a t. Because t makes more sense because we're doing it in terms of time. How long something is taking. Plus 30 here. So see if you understand this equation here. But of course, when you're plugging into your calculator, you want to make sure that this guy here is x in your calculator. Now we're going to ask you this. How long after reaching the low point is a rider 50 feet above the ground? Above the ground. So think about that. Which part, y of t or t, tells you 50 feet above the ground? That's positive 50, right? So how we would solve that is by doing 50 is equal to negative 25 cos pi over 20t plus 30. Now, you would do this by a calculator, of course, and I'm going to show you how to do the calculator, okay? You'd have to graph this guy on your calculator first, and then you would graph this guy as y1, this guy as y2, and you would see where they intersect. Okay, so before I show it on the calculator on the next video, I'm going to go like this. This graph is a negative cosine graph, so maybe it's going to look something like this, okay? This is y equals 30, of course, okay? It's going to go something like this, okay? And then you're going to also have what's my max? My max is 75, right? But I'm trying to look for 50. When is it 50? That my y1, my y2 graph is going to be that. My y1 graph is going to be something like this. Y equals 50, right? Because this one is y equals 50, and this one is your cosine graph. So if you think about what's happening here, it's going to tell you all the times that it reaches 50 feet. That's how you do this. And I'll show you how to do this on the calculator on the next video, okay? All right, bye!